Okay, so in this section, we're going to be dealing with some word problems that, or real world problems that we're dealing with, where we'll use trigonometry to help us solve certain types of application problems. So just like I mentioned, the goal here is going to be to solve various right triangle trig application problems. So what's going to happen is we're going to basically, I'm first going to define certain like kind of terminology for you first, so we know exactly when we see this terminology what it means. So the first type of terminology that you're going to deal with in some of these problems has to do with angle of elevation or depression. Okay, so you'll see that these have some similarities to them. Now obviously when we see angle of elevation, that means something that's going upwards. Angle of depression means some angle that we're going downwards in. So if I were to define these or to kind of describe each one of them, you'll see that the description is identical except one of them is moving upwards, the other one's moving downward. So an angle of elevation, this is the angle in which we rise with respect to any horizontal line. So it's important that we point out that this is to any horizontal line. Okay, so without the horizontal line, you'll see that we can't really even draw an angle. So an angle of depression same idea, except now we're going downwards. So this is the angle in which we move down with respect to any horizontal line. So if we take a minute and let me draw kind of like a picture as to how this looks. See, if I draw my horizontal line, see now I have some line to base my angle off of. So my angle of elevation would mean whatever the starting point is, this is the starting point, and we move upwards. So this angle that this line makes with the horizontal, this is our, we can call it alpha, that's fine, which is our angle of elevation. So you could see, I'm pretty sure you could even draw a picture for the angle of depression. Similar idea, right? You draw your horizontal and then you pick a point on your horizontal line, and then now you're going downwards to by some angle, whatever this angle is. So in this case, that alpha is my angle of depression. Okay, so let's actually look at a word problem where we'll be working with angle of elevation and depressions, and then we'll kind of solve it out, obviously with pictures. And you know, since our goal is to use trigonometric ideas, we need to force out a right triangle, because if you remember, trig functions rely mainly on right triangles. So let's look at this first example. So we would say that from the edge of a mountain, Mike notices some people 33 meters below. If the angle of depression from Mike to the people is 37 degrees, what is the distance from the people to the mountain? Okay, so for word problems, I think it's crucial that we can draw a fairly accurate picture. So here's what we're going to do. We're going to say this is the ground, and then the people are, let's say, here. And we know that from the edge of a mountain, so let's call this the mountain, for example. What is it that they're telling us? Mike notices some people 33 meters below, so that length is 33 meters because it's 33 meters below. That the angle, and if the angle of depression from Mike to the people is 37 degrees, so look, if I draw my horizontal line, here's where Mike is. So if I go down 37 degrees, that's my angle of depression. If I go down, I'll reach the people. Okay, then the question is, what is the distance from the people to the mountain? Okay, so in other words, we want to know what this distance is, which I'm calling x. So there's various ways we could solve this problem. One way is you could say, hey, look, we're assuming that the mountain makes a right angle with the floor down here where the people are. So if this is a right angle, so notice how I've created a right triangle. Now, what we can do is there's many ways we could identify other angles. But look at what I'm seeing here. This horizontal and the floor, or in the ground, since they're both horizontal, I'm treating them to be parallel. And if you remember from geometry, what is it that we knew? If we have two parallel lines cut by a transversal, alternate interior angles are congruent. So if that's 37, this is also 37 degrees. Now, another thing we could have done, was, for example, if I know that this angle is 37, and then I could figure this angle out because I'm assuming the horizontal and the mountain are perpendicular to each other. So then if that's 37, then this is what's left of 90, which would be 53 degrees. Now, in reality, it really doesn't matter which one of these angles you use. You could use any of the angles, but our goal is to solve for x. So since I have a right triangle, and we know that we can use trig functions with right triangles, I'm, for example, going to pick that angle. And with this angle, my goal is to do what? Use a trig function where I'll only have one unknown, which is just x. So because that's what I'm solving for. So if I look at this from this angle, what information do I have? Well, the unknown is what I want to make sure is in my equation, so the adjacent. And what other information is there? There is the opposite of this guy. So which trig function is opposite and adjacent? That's tangent. So I could then say, well then, tangent of 37 degrees will be 33 over x. And now, and once again, since 37 degrees is not a nice angle, we're going to have to use our calculator. Remember, it's only the 45, 30, 60s. And there will be some other angles which later on, I think that'll be in section 4, where we'll see that there are other angles where we don't need a calculator for. But this is definitely not a nice number. We need to use a calculator. So to solve for x, multiply both sides by x. I'm just trying to get rid of that from the denominator. So what do I get? X times tangent of 37 degrees equals to 33. Then divide both sides by tangent of 37. Then I get x equals 2. Now to do this, I need to use my calculator. What's 33 divided by tangent of 37 degrees? And that is about 43.79. But we were asked to round it to the nearest meter. So we can say, or let's just round this to the nearest meter. So the distance would be what? 44 meters. So the people are about 44 meters away from the mountain. Okay. If we want to be more precise, it would be 43.79 meters. But I'm just rounding it to the nearest meter. Okay, so now let's go on to the next type of application problem, which there's something else we need to learn about, which is called bearings. So, oops, that's bearings. So when we talk about bearings, so a bearing is a way of determining the direction of an object by starting from either a north or south line and rotating either west or east, and rotating either west or east. Okay, so we're going to basically, so for example, you'll see something like this. For if I would say south 42 degrees east. So you'll always see a north or south first, and then you'll see an angle, and then you'll see west or east. So what is this saying? Start from a point, draw a south line. So this is my south line, which I'm going down. From the south line, think of this as your initial side of your angle. I'm going to rotate 42 degrees towards the east, which is that way. So I'm going to rotate 42 degrees east, and that's the direction that the object is moving in. Now if it was 42 degrees west, I would rotate that way, and so on. So here's an example. So whenever you see this kind of notation, that's just bearing notation, which is telling you how to rotate to find the direction an object is moving in. So let's do an example where we'll kind of see what it is, how it would look in a word problem. So we have a large sign spans an east-west highway. Okay, so then we would say from a point "35 meters due west of the southern base of the sign a surveyor finds the northern base lies on a bearing of north 67 degrees east to the nearest centimeter, to the nearest meter. How wide is the sign? Okay, so once again, for a problem like this, we definitely want to draw the appropriate picture. So if I'm drawing the picture for this, what we're going to say is, look, we have, first we have a highway. So let's pretend that this is my highway, which is going east and west, okay? And then we have a sign that looks like this that spans through the entire highway. So this is the sign, right? So then what are we saying here? Then it says from a point 35 meters due west of the southern base of the sign. So that's the northern base, this is the southern base. So if I go 35 meters, so they're saying this point, let's say, which this distance from the southern base to that point is 35 meters, okay? So that's what, from a point 35 meters due west of the southern base of the sign, a surveyor finds the northern base, which there is the northern base, right? Lies on a bearing of north 67 degrees east. So basically the survey is here. It's saying, look, to get from here to that northern base, I'm going to have to go north, right? So from this point I go north, and I need to rotate 67 degrees towards the east, which it's that way. So if I travel in this direction, I will get to that northern base. Now notice how nice this is. We just created a right triangle here. Now they're saying to the nearest meter, how wide is the sign? So we want to find that length. So let's call that x, okay? So notice how I have this information. Oh, and here's something else. If this is north and this is west, north and west always form together to make a 90-degree angle. So if this is 67 degrees, then this small angle that's inside of that right triangle, that has to be 23 degrees. Now look at all the information I just created based off of the word problem. I have a right triangle. I have this angle, which to the angle to the 23-degree angle, I have the adjacent information, and what am I trying to find? I'm trying to find the opposite information. So once again, opposite and adjacent turns out to be tangent again, right? So I'm going to say, okay, using this angle 23, I'm going to say tangent of 23 degrees is equal to opposite, which is x, over adjacent, which is 35. So now I'm going to solve for x. To solve for x, I'm first going to multiply both sides by 35. And by the way, notice how I'm using my calculator at the very end. So once again, 23 degrees is not a nice angle, so I would have to use my calculator to find tangent of 23. But the point I'm trying to make here is, do I have to use my calculator at the end? Absolutely not. But since I'm rounding and my calculator is going to create decimals, I'd rather wait until the end and use my calculator. So first I'm solving for x. So those 35s will cancel out. So I get x equals to what? 35 times tangent of 23 degrees. So now I could use my calculator to find out what x is. And then we're going to round it to the nearest meter. So 35 times, so here it is, 35 times tangent of 23, which gives us about 14.85. So this is about 14.85 meters, which if I'm rounding it, it's about 15 meters wide. Okay, so that is 15 meters wide. And there you have it. So you'll see for homework that you'll be solving problems like this. The key is the picture. If you could draw a picture that creates a right triangle, then you could start using your trig functions to help you solve for the missing piece. Okay, so as always, if you have questions, don't hesitate to either ask in my office hours, or you could send me an email and I'll be more than happy to answer any questions you may have.